I want to talk about the immunotherapy in breast cancer. That was the authors were discussing in the article. And first of all, human breast carcinoma is the heterogeneous disease that have immunohistochemical biomarkers such as hormone receptor and human epidermal growth receptor 2, or shortly HER2. And it has different subtypes like luminal A, luminal B, HER2 enriched, and the triple negative breast cancer. And the luminal is most common that is found. It has approximately 60% of the whole breast cancers, and it has A and B variants. And luminal carcinoma is depends on the expression of the hormone receptors, such as estrogen receptor and progesterone receptor, that is strongly associated with the breast cancer. So luminal carcinoma is differentiated on the expression of the...
Sorry, 1 second. I can see the other slides. I only in the first one. Okay, now I think when you shared your screen,
okay,
in the presentation way, it's no, well, don't.
Yes, okay, I will.
You can in this screen. It's okay if you can keep in this screen. It's okay for me.
Okay then. Okay, good, no problem. So here is what basically I was talking about, the overall human breast carcinomas that is found in the human. And here is the types of the carcinoma disease that has luminal A and luminal B. That is depends on the expression of the HER, and Ki67 receptors. So luminal A is expresses HR positive, HER negative, and the low Ki67. And therefore, I made a mistake here. It's less aggressive, not more aggressive. While luminal B expresses HR negative, HER2 positive, and high Ki67. And that luminal is more aggressive. It's fast growing, and it constitutes of 20% of the breast carcinoma. And the therapy for this treatment on the luminal B, it's the use of monoclonal antibodies that targets specifically HER2 positive receptor molecule. And here is the third type of cancer, which is triple negative breast cancer. Triple negative breast cancer does not express the endocrine receptor, does not express the progesterone and the human epidermal growth receptor 2, as luminal cancer does. It is a different type of breast cancer, and on the other hand, it is highly heterogeneous tumor and constitutes of from 10 to 20% of the breast carcinomas, and it has a high rate of relapse, recurrence, and the mortality. It is difficult to treat this cancer because it has some immune avoidance, immune invasion. It can avoid the immune system, and but there is a treatment using neoadjuvant chemotherapy, or shortly NACT. And microenvironment of the cancer is really important. It plays a crucial role in the development of the cancer and its progression. So the microenvironment of the cancer, of all the breast cancer, is called stromal component. And breast cancer development, its metastatic ability and response to therapy is highly connected and associated with the stromal component. So, for example, adipocytes, endothelial cell, extracellular matrix component, blood vessel, immune cells are the part of the tumor microenvironment, or so-called stromal component. And this tumor microenvironment is highly dynamic because it keeps continuously secreting the chemokines, cytokines, and growth factors that results in the proliferation of the tumor cells, inhibition of the apoptosis, and the immune system suppression, which is the perfect ideal condition for the tumor progression. So here is the immunotherapy that was suggested using monoclonal antibody to target HER2 receptor. So basically, monoclonal antibody is found in the trastuzumab drug, and it have direct target on the domain 4th of the HER2 protein of the breast cancer. HER2 plus combination with the chemotherapy has become the conventional therapy for patients with HER2 positive early and late stages of breast cancer. So the main problem of the immunotherapy is that when the person is treated with the therapy or with the chemotherapy, most of the time it has either no effect or it has relapsing effect, that in further the person will the patient will have more severe version of the tumor, and the tumor itself will be more resistant to the immune cells, and it will avoid immune system easily by changing the gene expression, and that will remove some antigens that will immune cells will not be able to find those antigens, and just tumor will continuously proliferate. That is the one way of avoiding the immune therapy. So this image shows that the blocking HER2 signaling through the induction of the G cell cycle arrest and the inhibition of phospho Pi3K pathway, which induces the apoptosis and angiogenesis inhibition, inducing the antibody-dependent cytotoxic cellular killing of HER2 overexpressing using natural killer cells. So yes, and due to this, since this mechanism has proven and have a positive effect on inhibiting the HER2 receptor, it was approved by the FDA that this monoclonal antibody in the trastuzumab can be used as the agent for treating the patient that has a luminal B type of the carcinoma disease, which is expressing HER2 positive metastatic, and adjuvant treatment of patient in the early breast cancer identification. Yes, and this therapy has the capacity of inducing the ADCC due to the remarkable hematotherapeutic potency. And I haven't added the rest of the slides, but I want to say it verbally. The main problem of the immunotherapy, as I said, is the therapy resistance of the tumor cells, which is resulting in the tumor recurrence and the metastasis after the treatment. So how it is going? The tumor changes when the tumor occurs in the cells. It results in the gene. It results in changing of the gene expression pathway and antigen presenting pathway, which release the immune suppressive cytokines. Therefore, the receptors, antigen receptors that is found on the tumor is getting lost. So the mechanism that changes the TMA, the tumor microenvironment, results in the progression of the tumor after the treatment of comparing the immune cells and the repressing checkpoints. So another important issue is the checkpoints. I also haven't added here, but some tumor cells, type of tumor cells that they target the immune checkpoints of the immune system. Therefore, usually at G1 stage, thus stopping the cell from the apoptosis, from the cell death. And the ways that usually tumor escape the immune system is presenting less antigen on the surface, using the decreasing immune deficiency. And the second is the changes in the immunosuppressive tumor microenvironment induced by the T regulators, for example, or other T cells, therefore resulting in the upregulation of immune checkpoints receptor. And usually this type of method occurs due to the genetic instability and the immune selection of the process, and it can be inheritable to other generation of the cells.